Scholarly documents tailored towards individuals having knowledge of a particular domain are lengthy and complicated. Assimilating crucial information from them is both laborious and time-consuming. Our lay summarizer generates extremely short paper summaries, capturing the essence of the research work in layperson terms, restricting overly specific technical jargon. We also present our long summarizer that produces lengthier and comprehensive document summaries. An extended and insightful summary provides a deep understanding of a paper's various concepts to readers without them thoroughly analyzing the entire manuscript. Let us look at the challenges associated with scholarly document processing. Scientific research papers are composed of various sections and subsections. Any model for the understanding of such documents should therefore leverage such document structure. We do need to worry about aspects like summary coherence and saliency of information bits. Also, such a model should ideally judge how much attention to pay to each paper section. The systems we propose are simple, intuitive, and based on how humans judge each paper section's content for creating summaries. We conclude that the abstract is the most prominent section for layperson summarization based on multiple experiments. We train a transformer-based encoder-decoder model to generate the lay summary with the abstract as the source. In addition to text summarization aspects, the transformer learns to effectively transfer the text style from formal and scientific to a layperson one. For long-form summarization, we capture salient information from individual sections and also utilize a built budget module to calculate section-wise attention. Our built systems produce state-of-the-art results on the longsum and laysum datasets. We compute the average rouge scores between texts in individual sections and the target summaries from our available training data. Based on the overlaps, we ignore paper sections such as acknowledgements which do not contribute much to the summary. We also utilize these overlap scores to determine an attention weight distribution for the various paper sections. We'll review the lessons learned for lay summary generation. The paper abstract is the most relevant section, followed by the conclusion. A high Rougeil overlap points to some verbatim copying from the abstract onto the lay summary. On average, the conclusion section is shorter in length and therefore contains the salient points in a more condensed manner. We fine-tuned pre-trained transformer-based conditional generation models on the available training samples, experimenting with various sets of paper sections as the sources. Our results showed that training a BART large CNN architecture with the abstract as the only source was the best possible setting. Lay summarization not only requires modeling the saliency, but also has the additional aspect of neural text style transfer. For long-form summarization, introduction emerged as the most relevant section, followed by related work and results based on the section contribution studies. Based on existing evidence, we considered each paper section individually without the global context. We pre-trained the SummaRunner architecture on the PubMed dataset to mimic paper abstracts as closely as possible from all possible paper sections. This model was trained further on the long summarization dataset. The objective was updated to extract sentences, maximizing the Rouge 1 score between the paper sections and available long summaries. Our experiments show that even with a relatively simple neural summarizer at the base, the pipeline can produce state-of-the-art results on a blind test dataset. Automatic text summarization has always been a topic of interest at the Information Retrieval and Extraction Lab. The lab recently developed the Cross-Lingual Summarization Toolkit, dubbed CLSTK, and a workbench for rapid generation of cross-lingual summaries. We have also created extractive models for single and multi-document text summarization tasks, named Hybrid MemNet and HNet respectively. The lab also contributed to abstractive summarization efforts, proposing algorithms for multi-document abstractive summarization and also a novel semantic similarity metric. The lab's research on summarizing and presenting scientific content in a blog-like fashion led to the creation of SciBlogger, a step towards automating science journalism.